So for number 9, we have a swimming pool that is 15 by 30 feet with a consistent 5-foot depth. You are painting the walls and floor of the pool. If a gallon of paint can cover 250 square feet, how many gallons would you need to buy? Alright, so this is a surface area question because you're trying to paint the area of the swimming pool. I'm going to go ahead and write down some things. We know it's 15 by 30 by 5. And when one gallon of paint covers 250 square feet. Alright, so let's switch over and talk about this. So anytime we're doing surface area, we're talking about the area of every side or every face of the three-dimensional object. So I'm going to draw the worst swimming pool you've ever seen. And we're going to break it down and talk about what exactly we're measuring here. Oh, we have 6 sides to this rectangular cube or rectangular prism, and we need to know the area of each face, except for the fact that a swimming pool is not enclosed. So I'm going to color this portion in red because this is open. This is where you're coming up for air, so we cannot have this closed in. We're not going to be painting this section of the pool, but what we will be painting is these 2 faces on the outside, the faces in the, it'd be nice if we got a color change here on the back and front of the cube. If this starts to get confusing, I apologize. I am going to break it down, and then normally we would be solving for the top and bottom portion of it, but now we only need one side, so we need to know what the dimensions are: 30, 15, 5. And it's not to scale, obviously, because it's very obviously disproportionate, but so we need only one of this 30 by 15 face because we're not painting the top portion. So we're going to have 30 times 15 plus, so we're going to go ahead and write that as the top, or the bottom really. Hopefully that kind of, you can see the 3D shape, and what we're only worried about is the solid line. And then we need this 15 by 5, which would be these teal lines. Well, we have 2 of those, so we're going to do plus 2 times 15 times 5 plus, and then we're going to have 2 of the 30 by 5. Let's see if I can color that a little bit better. So 30 is this way and 5 is this way. So our 30 by 5s are going to be the dark blue lines. 30 times 5. So let's do that real quick. Well, 30 times 15 is 450 plus, and then we have, let's do this one next. 150 times 2 is 150. And 15 times 5 is 75, times 2 is 150. Times 2 is 150, and then can't have both of those be 150, that's double, so this one's actually 300. We actually worked the problem correctly, and we'll be good. We have 750, 850, 900. I just added these 3 up really quick because my daughter's standing here watching me make the video, trying not to talk and laugh, and it's driving her nuts. So we're gonna go ahead and move right on. So we have 900 square feet total needs to be painted here. Well, one can does 250 square feet. So we're going to need 4 gallons, because if we only bought 3 gallons, we'd only be able to cover 750 square feet, which is not enough. So we need 4 gallons of paint. Is that an option? Yes, it is. And it's option C. For this video, please excuse my voice. I just got back from the doctor, diagnosed with strep throat. So I might be cracking a little bit or losing my voice. I'll reshoot it in the future, but I have time to make the video now. So I'd rather get it out than not have it. So we're going to start with problem number 10 on this video, and we're looking at the same swimming pool from problem number 9. And we're just going to really quickly rewrite or redraw the swimming pool. It's not going to be great. Not that the other one was, but just so we have a visual. So here's our swimming pool above ground. We know that it is 15 by 30 by 5. And it looks like on this problem this problem we're going to sit here and talk about it for a minute, because this one is very confusing in what it asks, and I see a lot of people go the division route here instead of the multiplication route. So we're going to read it and pull it apart and see what it really says and what it's asking us to do. You need to fill the pool with water. If 1 cubic foot equals 7.48 gallons of water, so we know 1 cubic foot, which is feet cubed, is equal to 7.48 gallons. Let's just write down the key information like we always talk about. How many gallons will it take to fill the pool? So that's going to be important. I'm going to underline that because I don't want to forget. How many gallons will it take to fill the pool in the previous problem? 15 by 30 by 5. Okay, so the volume of a rectangular prism is simply the height times depth times width. So we can do 5, 15, 30. Doesn't matter which one you pick on this, because you can do 30 times 15 times 5 or whatever in any order, and you're going to get the same answer. Let's see, we got 150, and then I know 15 times 15 is 225, so I should have 2250. 2,250 cubic feet of water. Alright, so we've kind of covered everything here, but now we need to know if 1 cubic foot equals 7.48 gallons of water, how many gallons will it take to fill the pool in the previous problem? We know what the size of the pool is, we know how much water it's going to need, and we know that 1 cubic foot is equal to 7.48 gallons. So pause the video, or I'm going to leave you a second to think about it. What do we do to figure out how many gallons we need? Okay, so we're going to look at, we have this many cubic feet. So I'm going to go ahead and rewrite that because I know that's going to be important. And I know that 1 cubic foot is equal to 7, we'll call it 7.5, but we're not going to use it that way. 7.48 gallons. So for each cubic foot, I need this many gallons of water. So I'm going to multiply that out, and I'll get, that's really the only answer that makes sense. We're multiplying 374 is division, or we have to divide this number because it's less than. This number is larger, so I'm going to circle it. 300 is also going to be subtraction or repeated subtraction, which is a division. And then 2250 is the number of cubic feet of water. Not how many gallons that we need, it's just the number of cubic feet. And that's why that option's there, because you'll do the math and you'll say, oh, I need 2,250 cubic feet of water to fill this pool. So there's my answer. It looks good. I did the math. I got that. That's not correct because we need to know how many gallons you're going to use. And 1 gallon is 7.48 cubic feet. This one and this one, A and C, should have just been outright. You're not dividing here. It's multiplying. You need to know how many go into it. And that would be the confusion where some people would say, well, let's divide. But it's not how many gallons go into it. It's how many gallons are per cubic foot of water. So that per is going to give you the clue that we're multiplying here. All right, let's move on to number 11. All right, number 11 says, pencils sell for 98 cents per dozen. How much more per pencil does it cost to buy 5 at 50 cents each? Or 5 for 50 cents, I'm sorry. If it was 50 cents each, we'd already have the answer to that one. Let me finish erasing the previous problem. Okay. So we know we can buy pencils sell for 98 cents per dozen. So 12 for $0.98. How much, and then see, how much more per pencil does it cost to buy 5 for 50 cents? Oh, what I'm going to do here is I'm going to go ahead and we're going to move our decimal 2 places over just to have a nice whole number instead of a fraction or a decimal. We're at 50 and 98 cents. We're switching from the dollar price to the cents price, which is why we moved it 2 times over to the right. And then we're going to look at it as a proportion. Well, if I'm paying 50 cents for 5 and I'm paying 98 cents for 12, I need to figure out what those are as a decimal number and then move on from there. All right. Excuse me. Well, this is very obviously going to be 10. So these are 10 cents each. And 98 divided by 12 is close to 8. Let me put on the calculator real quick. And I got 8.17 each. So what do we do from there? Well, the question asked, how much more per pencil? Now we do have the per pencil price here. So what we just figured out, 10 cents each and 8.17 cents each. How much more per pencil does it cost to buy 5 for 50 cents? Well, let's just say how much more. So we're looking for the difference in the price. So I'm going to take, let's change our color. I'm going to take the price for 5 for 50 cents and subtract it from, I'm going to subtract the 98 cents for 12 price and see what we get. Well, don't need a calculator for this one. We already know that there's a whole number difference of 1 and I would have to borrow, and to get that other 1 that we would have brought over, it's going to be 83. So we have, it's $1.83 more per pencil. See if that's an option. Yes, it is. Option C for number 11. So that's that. Yep, always try and get what you're looking at in the same unit price or base price. You wouldn't compare inches to feet or meters to inches. Try and convert everything to the same unit of measurement. In this case, we went from partial dollars, 50 cents, 98 cents, $0.98, $0.5 to cents. So we had 98 whole cents, 50 whole cents. So we had a fair base to compare both of these purchases on. Number 12, the testing center starts at the test at 8:40 a.m. If you have 90 minutes to complete the test, when does the test end? So it's saying you scheduled your GKE exam for 8:40 a.m. You have 90 minutes to take the section you registered for. What time can you tell your ride to be there at the latest? Because you may finish early, but this is not what they're asking. They want to know, when are you going to be forced to stop taking the test? So we have 90 minutes, and we're going to look at that, break it down, and show you a little trick for working with time. That if you can't do it mentally, this usually helps a lot of people. So let's switch over. So we know we're starting at 8:40 a.m., which I have written already up here, and I'm rewriting. You have 90 minutes, so we're going to look at 90 minutes first. Well, we're going to subtract 60 minutes, or 1 hour. We'll be left with 30 minutes. Well, 30 minutes is half an hour. So we now know that we have 1 hour plus 1/2 an hour total time to take this test. So I'm going to come here and do, and we know that 1/2 hour is, well, 30 minutes. So what I'm going to do here is add my 1 hour and 30 minutes to my time. And this will leave me with 9:70. Well, what does that mean? Well, now we can do the same thing here. We're going to subtract 1 hour, or 60 minutes. And then we're going to go back and we'll say we'll have 9:10 left. Now I'm going to add my 1 hour in as an hour, 1 whole hour instead of 60 minutes. I'm going to have 10:10. Now the question does specify that it's 8:40 a.m. and you have the option of 9:30 a.m., 10:10 a.m., 10:40 a.m., or 10:30 a.m. So let's go with 10:10 a.m., which is option B on the test. That's one way to do it. The way I do it is I just look at it and I say, I know I have 90 minutes. So that's an hour and a half. So an hour and a half to here. Well, if I look on the clock, I'll be at 8. Going halfway across the clock, I will be at 2, which is equal to 10. And I know that I've crossed the hour mark, so I'll just add 2 to that, and I'm at 10:10. I hope that makes sense. If it doesn't, let me do it one more time. So I started at 8:40. I already know I have 1 hour, so I'm already going to say I'm at 9 o'clock. Well, 9:40. And I know I have 30 minutes left over, so I'm going to go from 8, where I started, halfway across the clock to the 2, which is 10, which means I'll be at 10:10. It's that simple for number 12. Alright, let's look at number 13. The distance between Brookville and Center City is 17.25 centimeters on the map. If 1 centimeter is equal to 20 miles, how far is it between the two cities? So let's see, what is it asking us? It's asking us to look at a map, and you know we have the legend at the bottom and the scale that kind of shows us 1 inch is equal to 1 mile or whatever. They're giving us the scale already, so we don't even have to worry about coming up with any of that. We know that the total distance between Brookville and Center City is 17.25 centimeters, and we know that 1 centimeter is equal to 20 miles. All I want to know is how far is it between the two cities. Alright, so we have 17.25 total meters. So if we have point A, which would be Brookville, and then we will have point B, Center City. There's 17.25 centimeters between them. So I'm going to take 17. I'm going to break it up so I can do it mentally. Times 20 plus 0.25 times 20. And I'm going to end up with 2 times 17 is 34. I have my 0, so I have 340. And then a quarter of 20 is 5. So I have a total of 345. Use the calculator on this one if you're not comfortable with it, but that's just one way to do it. And if you don't know what I did, look at my multiplying numbers mentally video. It's on my YouTube and my website, and that'll kind of show you how I broke it down and made it really easy to do. Alright, let's go to 14. The candy shop sells a box of mixed chocolates. The box of chocolates contains 12 ounces of chocolate covered caramels, 14 ounces of chocolate covered cherries, and 6 ounces of chocolate covered raisins. That's not how I'd spell raisins, but I guess I'd spell it wrong. How many pounds are in the box of chocolate? So what do we need to know here? Well, we need to know how many ounces are in a pound. How many ounces equals 1 pound? And we need to know the total number of ounces we have. Well, 26. Yeah, 10 to 32 ounces total. Well, luckily the the center will give you your reference sheet, and we can come right in here. Let's see here. 1 pound is equal to 16 ounces. So now we can fill in this question mark. Know that 16 ounces is equal to 1 pound. So all I have to do is take the total number of ounces I have divided by the number of ounces in a pound to see that I have 2 pounds of mixed chocolates. It's a pretty easy one. Really just appreciate the fact that you're given the reference sheet on this test. It makes things so much easier. You don't have to come in there memorizing everything. You just need the skills and the know-how to put the questions into mathematical terms and solve them really quick. It's not a force a bunch of stuff into your memory type of test, so we're fortunate for that. According to the rain gauge, how much rain has fallen? Well, we know the thick lines here are marked off in 1 inch increments, And we have our options of 2.7, 2.2, 2.5, 2.4. So we know we're already going to be answering a 2 here, and that's pretty evident once we look at the gauge. But what we need to do to figure out the fraction portion of this is how many bars are there between 0 inches and 1. We have 1, 2, 3, 4, 5. Okay, so each one of these bars is 1 out of 5 increments. So how do we figure? Let's scale this up to a out of 100 so we can get a percentage or a decimal number easier. Well, 20 times 5 would give me 100 in the denominator, so 20 times 1 would give me 20 in the numerator. So each one of these increments is worth 0.2 inches. And we're going to write it in check. Well, yeah, that works out, so we're good to go. So now we know that this is going to be 2.4. Let's see if that's an option for us. Yes, it is. Option D. Let's move on to number 16 now. Number 16 has the question: early civilizations used the cubit system. Use the cubit as a unit of measurement. The cubit is the length from the middle finger to the elbow. Estimate the average height of a man in cubits. Well, we're not even going to deal with numbers here, really. I mean, it's an estimation, and it's more of a common sense problem. So what do? Well, on the test, what I would do sitting in the testing center is put my hand up, not to call their attention, but out in front of me, and look from my middle finger to my elbow and kind of figure out, well, I'm not the average height of a man. I'm a little bit taller. I'm 6'4", so I think the average is 5'9". But I think, and I'm not a biology major in any sense of the word, I would think we're pretty much proportional. I don't have the arms of a man who's 5'9", and the rest of me is 6'4". So I'm going to say, well, I think it's pretty reasonable that from my middle finger to my elbow is about the same distance as my bottom of my foot to my knee. And I think, well, that's about a quarter of my body. So if humans are proportional, which I'm not professing that they are because, like I said, not a biology major, I'm going to say that from the tip of my middle finger to my elbow is about a quarter of me. I'm going to assume that's pretty constant for all humans. And I'm going to look at the options they've given me here. I'm going to say, well, I'm very lucky here because I know for a fact that option A, 6 cubits. So that would mean from the middle finger to my elbow is 1/6 of my total height. So I could take that distance, holding it up, looking at it, and go, no, I'm definitely less than 6 times that height. 2 is ridiculous. I'd be half the size I was, which makes sense. I'm estimating 1/4. Quarter is 1/2 of 1/2. So yeah, I would be cut off right at the midsection. And 10 cubits is insane. I wouldn't. So just for an estimate and no real numbers here, no proof, nothing, just thinking it through, 4 cubits makes the most sense. Let's see what number 16's answer actually is. I don't want to, because we're not using math here. 16 is B. Yeah, 4 cubits. That makes the most sense to me. I hope that makes sense to you. I hope my rambling and my thought process, trying to explain it, didn't confuse you or make things worse. I really wasn't going for that. I just kind of rambled out what I thought, but 4 cubits makes the most sense to me, and it also makes the most sense to whoever wrote this question. Alright, let's move on to 17. Jay traveled from Miami to Jacksonville, a distance of 320 miles. He left Miami at 8 a.m., stopped for lunch for 30 minutes, and stopped for 2 15-minute breaks at rest areas. He arrived in Jacksonville at 2:15. What was his average rate of speed during his travel time? Boy, that's a heck of a question, so let's kind of break it down. I can kind of feel people getting nervous here, because these are those questions like when you're watching cartoons and stuff, they always make fun of math and say, well, if a train leaves station at... But that's not what we're really doing here. We're going to take it apart and make it really easy to understand. So we know he went 320 total. Well, my pen's not working. My pen doesn't even want to participate. 320 total miles. Okay. He left at 8 a.m. Now this is one of those problems when I'm telling you, on the ones you're confident in, don't spend the full 2 minutes on, because there's going to be one that, even though it's easy, you're going to need the time no matter what. This is that question. You want to make sure you get every detail. Even though it's not a very hard problem, it is still a problem with a lot of information. And spending the full 2 minutes that you would have if you equally partitioned every question out just to get the information on your page that they give you to write on is a very valuable idea. Spend another minute, go up to 3, even 4 minutes on this type of problem to make sure you have all the information and you've done the math. Go through those order of operations ones as quick as you can, confidently, and save that time you're banking for these types of questions. Okay, so now let's get back to it. He stopped for 30 minutes. And 2 times he stopped for 15 minutes. So that's going to be important. What was his average rate of speed during his travel time? Let's not even look at that yet. Let's think about a few things here. Oh, and I'm sorry. And he arrived at 2:15. So we need to look at how long did he stop? Because if you think of a line graph of his travels, here's where he stopped. He's driving, getting to Jacksonville, stops. He's not making any progress. Then he drives. He's almost there. Then he stops. Then he arrives at his destination. So we have 2 times here where he stopped for 15 minutes and made no progress. Okay, so we really need to subtract that out of there because they just want to know what his average rate of speed during his travel time. Not his cumulative time, but his travel time only. So only the times where we're moving, which I'll color in underneath so it's kind of easier to see. And we do not want to calculate this in his average speed, sorry. Okay, so we can go ahead and say, well, 30 minutes. It's not making it confusing. Plus 2 times 15 is another 30 minutes. Is equal to 1 hour. So these 2 breaks plus his lunch, which I guess I didn't represent here. Let's just say here's lunch. So we're also not including that. Comes to a total of 1 hour. So we can see his total time from 8 to 2:15 is, well, 4 hours would get us to noon. 2 more would get us to 2 o'clock, so that's 6. And 15 minutes is a quarter of an hour. So a quarter of an hour is 2:5 or 15. So it took him a total time of 6 hours and 15 minutes. Now we can subtract 1 hour for his breaks. And we'll have 5 hours and 15 minutes total driving time. Excuse me. So now we know the key piece here. He went 320 total miles and he drove for a total of 5 hours and 15 minutes. And if we go back to the question, we'll see that they're more concerned. What was his average rate of speed during? And that's our keyword, during. That's why we did take the hour total out. His travel time. So now we're going to look at it and say, well, 5:15 is equivalent to... that's an interesting mistake. 5.25. And if you want to know why I'm saying that, here is our clock. Noon, 3, 6, 9, 15 minutes is the same from 12 to 3. And if we look at this as a fraction, that's 1 out of 4, which is equal to 0.25. So that's why I've converted it to 5.25. You can't really do miles divided by time in the time format that we're used to. So we know we went a total of 320 miles over 5.25. And I believe the reference sheet even gives you the distance formula of D equals RT. Let me see. Yep. So let's switch over. So if you absolutely didn't know this, your distance formula for driving and stuff like that is distance times rate times time. And we were given the distance. Let me switch back over and show you why we're doing 320 divided by. So we have DRT, or dirty, that's how I remember it, and I'm sure everyone else does. Well, what were we given in this problem? The distance and the time, which we've come up with here. So we need to know the rate. So if I divide by t, I'm going to get d over t is equal to the rate. So let's go back and let's erase this section. And remember, you can manipulate any equation like this. That's kind of the whole idea of playing with variables in algebra when you first start learning it, where they don't include numbers yet. So now that we know that dt, d over t is equal to the rate, we're going to take our distance, which I've shown you already at 320, and our time, 5.25 hours, and we're going to divide them out, and we're going to get 60. Let me put it in the calculator. So an exact answer is 60.9523809.5. Now this is an interesting answer. This is not one that I would agree with putting on the test in this way, because every other problem on this test, anytime we do anything on this test, we always round to the nearest tenth. So you say, well, that's, and if you look on the answer, there's 60.9. You say, well, that's it. There's nothing else. I have 60.9 here. But let's think about this and be honest for a second. If I were to round to the nearest tenth, look what we have here. We have a 5, which will push this into, plus 1, which will make this actually, well, that's interesting, 61. That's not an option on this test. That's not an option as an answer. So now you've done everything you've been told forever. All the advice I've given you, round it to the nearest tenth. Always do that. Always do that. But now it's not an option. So what do? Well, you go with the closest answer to the correct answer. And that's 60.9, right where you started. So we're going to do a final answer of 60.9. That answer really irks me. It's not right. Everything you ever learn, everything you're going to teach your students, everything you tell your students, round to the nearest tenth on these types of tests. Pi is not 3.14159 on these tests, it's 3.14. And now here we are taking a professional exam to get certified to teach this stuff. And we're breaking the most common rule we're going to give our students. It drives me crazy. But we're going to move on to number 18. Alright, go back. Number 18. Jackie is building a dollhouse with a scale of 1 inch equals 12 inches. She wants to put a sofa in the dollhouse living room. If a full-size sofa is 72 inches, how long will the dollhouse sofa be? It's a little bit different. I don't think we get many proportions like that for building dollhouses, so let's do that. I like this one. Sorry. So, let's switch over. And we know that, well, let's write it out first. We know scale of 1 inch equals 12 inches in the real world. So 1 inch in the dollhouse is equivalent to 12 inches in our house. She wants to put a sofa in the dollhouse living room. In our world, the sofa is 72 inches. Let's write that down. But how long will it be in the doll's world? It's pretty easy. We can set it up as a proportion, or we can do it straight to the point. But let's do it by proportion first, then I'll talk about straight to the point. So we know in this world of the dollhouses, 1 inch in our world is equal to 12 inches in their world. So that's just a ratio. It's the same as saying 1 to 12, where this is now our numerator and this is now our denominator. And now we're saying, well, in our world, our sofa is 72 inches. How long is it going to be in the doll's world? Well, we're doing a proportion, so we're going to cross multiply. We're going to get 72 is equal to 12x. We'll divide by 12. X is equal to 6. Is that an option? Who's building the doll? Jackie. Is she going to consider a 6-inch sofa for the dollhouse? Yes, she is. That's option B. So that's pretty easy. I think we covered that right away. I don't know how else to do it with the long drawn out process. But what I can show you this really quick. What I would do on the test, and this is one of those ones where I'm going to bank a lot of time. As soon as I read that question, I'm going to say, well, I know 1 inch in our world is 12 inches in their world. I know in our world, this sofa is 72 inches. So I'm just going to take 72 divided by 12. I'm going to compare just the dolls, because we have a 1 here, especially since we have a 1 here. This makes this really easy to do. I'm going to go with our world divided by their world, because it's a 1 inch. So that's it, 6. And there I banked a minute and a half for the previous problem, even though my nerves have probably gotten to me at this point, and I'm thinking, oh, I need to make it up. How fortunate am I to make it up on the very next problem?